This is TWiT.
Docker is open source software. It's a simple tool that you install on any Linux machine, hopefully soon any Windows machine. And what it does is it helps developers package up their applications in a format that is easy to move around from machine to machine, and then can be executed in a sandbox environment in a repeatable way, meaning the same thing happens on any of those machines, or at least something predictable happens. And that gives developers a really useful building block to assemble applications, especially what we call distributed applications. So applications that are made of multiple software components talking to each other over the network across many machines, right? So clouds, backends, web applications, things like that. And yeah, that's what Docker does.
Well, that sounds like a problem that's been solved many times. What's different about Docker that makes it the new cool thing that all the kids want to get into?
Yeah, so I think, well, a few reasons, I think. The first is that, well, first of all, the technology has existed for a while, although it matured fairly recently. So Linux containers, et cetera. Linux containers are one of the building blocks on top of which Docker is built. We did not invent that. One thing that is new in how Docker approaches it, though, is instead of thinking of it as a low-level building block for sysadmins to start servers, instead of thinking of containers as just miniature servers, VMs that start more quickly, instead we looked at it and said, oh, we could use this and make it available to developers for their needs. And I just explained that the need, package up your application and move it around. So that's been done before, but usually in a very language-specific or platform-specific way. So if I'm a Java developer, I've got jar. I can package up my Java application and move it around, no problem. If I'm a Python developer, I've got PyPy to distribute my packages. I've got pip install. I've got a whole setup. If I'm using Ruby, I've got gems, etc. So each stack has its own proprietary dedicated tools. The problem is that these new kinds of applications, these distributed applications that are typically what developers are building today, are not limited to one of those language stacks. Typically, over time, you have pieces in many different languages. You want to mix and match. You want to expose each functionality as a service. You don't want other components to worry about which language it's written in. And that's just what developers do. The problem is, if that's the scope of your application, then you don't really have a building block for packaging all the pieces in the same way across your entire application. And Docker does that because it's not language specific. Its abstraction layer is focused on things that are true across all Unix-y systems, processes, files, sockets, things like that. So it's agnostic.
Cool. And I think one thing that I see so far in Docker that makes it really different from how at least companies I've been working for have been doing this is that rather than go through, say, using the Perl CPAN tools or using the Linux packaging stuff, rather than go through each individual VM and install everything there, we instead do, you install it all once and you get this binary that you can then layer onto your basic stack. So you're doing the installation expense only once. Is that a fair way to characterize that?
Yeah. So, what if you know what a static binary is, the approach is to compile everything in and then move the whole thing around. There's Docker helps developers bundle, and sometimes it creates frictions because the typical way that a Linux distro sysadmin wants to install and manage software is the opposite, right? It's centered around the workflow of the operator and the ability to actually change on the fly dynamic libraries and change some dependencies under the feet of the application. And so there's an emphasis on control and kind of only making changes when you're sure you know exactly what's going to happen. Meanwhile, the developer is preoccupied with a different kind of control. If I'm a developer and I've built my application on my machine, and it works. It works when I've built it on a very specific version of different libraries, right? And it works because it's hitting a very specific version of my favorite database, et cetera. The configuration is done in a very specific way. All of that is part of my application, really, because if I change it, the application might not work, or it might work differently. So what I want as a developer is I want to package all of that, and I want to distribute all of that together. I don't want people to mess around with it, because if people mess around with it downstream, it's not my application anymore. So that's how, for example, iOS and Android apps are built. And it's been very successful because applications don't interfere with each other. You don't have, what used to be called DLL hell, right? Or we call it the matrix from hell. Same codes on different machines with different dependencies, different results. Here, it's always the same thing. And that's very appealing to developers. And it results in applications that are more predictable. The quality is better, you can ship faster, et cetera.